everyone, Dennis here. In this video, I'm going to discuss with you GCE O-Level Physics October-November 2019 paper 2. Subject code is 6091. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. Figure 1.1 shows the velocity time graph of an athlete for a 100-meter race. A. State the time during the race when the acceleration of the athlete is largest. 1 mark. So this is the velocity time graph, and if you want to determine acceleration, we need to look at the gradient of the graph. So I want to find the largest acceleration. From this graph, we need to find the point with the largest gradient. So this is the point with the largest gradient, and the time is 1.8 seconds. B. The velocity of the athlete is always positive, but his acceleration is sometimes negative. Explain this statement. 2 marks. So velocity and accelerations both are vector quantities. For velocity, the sign positive and negative tells us the direction. So if it is always positive, it means that he is moving in the same direction. So to explain the first statement, the velocity of the athlete is always positive shows that he is moving in one direction. On the other hand, if the acceleration is negative, we call it as deceleration. So deceleration means the velocity decreases. So to explain the negative acceleration, we can say that when his acceleration is negative, his velocity is decreasing, but his moving direction does not change. C. State how a student can use figure 1.1 to show that the race is 100 meters long. 1 mark. Since this is velocity time graph, to determine the distance traveled, we just need to find the area under the graph. Hence, to answer this question, the student can find the area under the velocity time graph from 0 to 9.8 seconds, which represents the displacement traveled for the whole period. D. Determine the average speed of the athlete during the race. 2 marks. So we just need to apply the average speed formula, which is the total distance traveled divided by the total time traveled. So just plug in the value, total distance traveled is 100 meters and the time is 9.8 seconds. Calculate with calculator, we'll get 10.2 meters per second rounded to 3SF. Hence, 10.2 meters per second is the answer. Question 2. Figure 2.1 shows a thin metal sheet. It swings from side to side about a pin through a hole at A. The center of gravity of the sheet is at point G. A. State what is meant by the center of gravity. 1 mark. Alright, to answer this question, just write down the definition of center of gravity, which you can find from the textbook. So the center of gravity is a point on an object where its weight seems to act on the point. B. The line AX is horizontal. The line XG is vertical. AX equals 0.30 meters, XG equals 0.40 meters, and GA equals 0.50 meters. The mass of the sheet is 250 grams. The gravitational field strength G equals 10 newtons per kg. Determine the moment about the pin at A of the weight of the sheet in figure 2.1. 3 marks. Alright, before we want to determine the moment, first we need to determine the weight of the metal sheet. We use this formula, W equals mg, where the weight is pointing downwards. Then we substitute the value, the mass given 250 grams, we convert to kilograms, it will become 0.25, and the G given is 10. Hence, the weight of this metal sheet is 2.5 newtons. Next, we apply moment's formula to determine the moment. So M equals the force F multiplied with the perpendicular distance D. So for this case, our force is the weight, and the perpendicular distance with this force is AX. Then we substitute the values. The force is the weight, which is 2.5. The perpendicular distance is AX, which is 0.3. We calculate, we'll get 0.75 newtons meters. Since moment is a vector quantity, we also need to mention about the direction of this vector. So for this case, it is the clockwise direction. Hence, the answer is 0.75 newtons meters clockwise. C. The sheet eventually stops with point G directly below A. Explain why the sheet stops at this position. 1 mark. Okay, so when the metal sheet stops swinging, it means that the moment is 0. So how can we have 0 moment? So for this case, if the perpendicular distance between the pivot to the point G equal to 0, then the moment will be 0. So to answer this question, here is what you can write. When point G is directly below A, the perpendicular distance between point G and pivot A is 0. Hence, moment is 0 and the sheet stops at this position. Question 3. Figure 3.1 shows the path of a metal ball fired into the air at an angle to the horizontal. Air resistance has a negligible effect on the motion of the ball. A. At point A, the ball has kinetic energy. At point B, the ball has kinetic energy and gravitational potential energy. State what is meant by kinetic energy and by gravitational potential energy. Okay, so you have to explain kinetic energy and gravitational potential energy for 2 marks. So just apply the basic concept here. Kinetic energy formula is half mv square. So kinetic energy is the energy that a body contains due to its mass and its speed. For GPE, the formula is mgh, where the definition is gravitational potential energy is the energy that a body contains due to its mass and its position in a gravitational field. B. The metal ball has a mass of 1.5 kg. The speed of the ball at A is 20 meters per second. 1. Calculate the kinetic energy of the ball at A. 2 marks. Okay, so to calculate the kinetic energy, just apply the formula half mv square, then substitute the values given. M is 1.5, V is 20, and we will get 300 joules. Hence, answer is 300 joules. Part 2. The kinetic energy of the ball at B is 180 joules. Calculate 1. The gain in gravitational potential energy of the ball as it moves from A to B. 1 mark. Okay, so to get the gain in gravitational potential energy, it is equals to the loss in Ke. Now for this case, to get the loss in Ke, we will take the initial kinetic energy, which is 300 joules, where we get this value from part A, and then minus the kinetic energy at point B, which is 180 joules, and we get the value 120 joules. So answer is 120 joules. 2. The change in vertical height h of the ball as it rises from A to B. Take the gravitational field strength G as 10 newtons per kg. 2 marks. Okay, now for this case, we can use the GPE formula mgh. Then we substitute all the values that we have. So gaining GPE is 120 joules, the M is 1.5 kg, the G is 10, and we want to calculate h. So h will be 120 over 1.5 times 10, and the value is 8 meters. Therefore, answer is 8 meters. Question 4. A student pushes inwards the piston of a bicycle pump with his finger blocking the other end, as shown in figure 4.1. The temperature of the trapped air remains constant. The volume of the trapped air decreases and its pressure increases. A. Use the ideas about molecules. Explain why the pressure increases. 2 marks. Okay, so remember that there are two factors that can change the pressure of air, which is the temperature and the volume of the air. So for this case, the temperature is constant. So in other words, when the volume changes, then the pressure will change. Okay, so they are inversely proportional to each other, which means that when the volume decreases, the pressure will increase. So why is this so? The reason is because when the volume decreases, the number of air molecules per unit volume increases. The frequency of collision by the molecules to the wall of the piston increases. Hence, pressure increases. B. He repeats the experiment with the bicycle pump filled with water instead of air. He applies the same force and the volume of water does not change. Using ideas about molecules, explain why the volume of water does not change. 2 marks. Okay, so for this case, he has changed the medium from air to water. Remember that water cannot be compressed and air can be compressed. So if you want to use the idea about molecules to explain why water cannot be compressed, so this is how you can explain. The molecules of water are closely packed together. They have intermolecular forces acting between them, leaving very little space for further compression. Hence, the volume of water does not change. C. The student connects a different pump containing air to a mercury manometer as shown in figure 4.2. There is a pressure difference between the air inside the pump and atmospheric pressure. This pressure difference supports a height h of mercury. 1. On figure 4.2, mark and label the height h. 1 mark. Okay, so the height h is the height difference between the two sides of the manometer, and you can mark it in this manner, h. Okay, then part 2, the pressure inside the pump is 1.8 times 10 to the power 5 Pascal, and atmospheric pressure is 1.0 times 10 to the power 5 Pascal. The density of mercury is 14,000 kilograms per meter cube. Calculate h. 2 marks. Okay, so for this case, to determine the h, first we need to understand that the pressure at the same level will be equal. So for this case, the P1 will be equals to P2. For pressure number 1, the pressure comes from the pump, so P pump. For pressure number 2, the pressure comes from the atmospheric pressure, P ATM, and also the pressure from the mercury, PHG. Okay, and now for pressure from the pump, given 1.8 times 10 to the power 5 Pascal, atmospheric pressure is 1.0 times 10 to the power 5 Pascal. For the pressure of mercury, we can apply the formula rho GH. Okay, we know that the rho given is 14,000 kg per meter cube and the G is 10. Alright, and we calculate the H, we'll get 0.8 times 10 to the power 5 over 14,000 times 10, and the answer is 0.571 meters rounded to 3 significant figures. Question 5. A. A student measures the speed of sound using an echo from a cliff. She stands facing the cliff and claps her hands as shown in figure 5.1. The echo arrives 3.6 seconds after she claps her hands. She walks 200 meters towards the cliff and then claps her hands again. The echo now arrives 2.3 seconds after she claps. Calculate the speed of sound using this data. Give your answer to an appropriate number of significant figures. 3 marks. Okay, so to answer this question, let x to be the initial distance between the student and the cliff. So this is the path that the sound travels after she claps. So from the student to the cliff and then bounce back to the student. Hence the distance traveled is 2x. So initial speed v1 will be 2x divided by the time 3.6. Next, she walks 200 meters towards the cliff and claps her hand again. Alright, so here is the new position of the student after moving 200 meters forward. So this is the distance between the student and the cliff after she moved 200 meters ahead. And this is the total distance traveled by the sound after she claps her hand. So which is 2 times of x minus 200. So the speed after moving, which we can label as v2, will equals to 2 times of x minus 200 divided by the time 2.3 seconds. So since the speed of the sound is always constant, then we can say that v1 equals to v2. Then we just substitute v1 as 2x over 3.6 and v2 as 2 times x minus 200 over 2.3. Then we solve this equation by cross multiplying this equation. We get 4.6x equals to 7.2 times the x minus 200. Expand the bracket, and 2.6 will equals to 2.6x equals to 1440. So x will be 553.846. So the speed will be 2 times of 553.846 divided by 3.6. Then we get about 308 meters per second. This value has been rounded up to 3 significant figures. B. The student produces a musical sound. State how the sound heard changes when 1. The amplitude of the sound decreases. 1 mark. 2. The wavelength of the sound decreases. 1 mark. Alright, so the answer for part 1 is the loudness of the sound decreases. So remember that the loudness of the sound is determined by the amplitude. So when the amplitude decreases, the loudness of the sound decreases as well. So the answer for part 2 is pitch of the sound increases. Recall that the formula of wavelength V equals to F lambda or F equals to V over lambda. So from this equation, we can see that frequency is inversely proportional to wavelength. The lower the wavelength, the higher the frequency. So sound with higher frequency has higher pitch. Therefore, this explains the answer for part 2. Question 6. A. 2 resistors of different resistance are connected to a battery. Insert the appropriate electrical quantity in the gap in each of the following sentences. When the resistors are connected in series, the something is the same for the 2 resistors. When the resistors are connected in parallel, the something is the same for the 2 resistors. 1 mark. Okay, so we need to fill in the blank. So the answer for the first blank is the current is the same for the 2 resistors when the resistors are connected in series. For the second blank is the potential difference is the same for the 2 resistors when the resistors are connected in parallel. B. A resistor of resistance 1000 ohms is connected in series with a thermistor and a battery of EMF 6.0 volts. Figure 6.1 is part of the circuit diagram showing the battery and the resistor. Part 1. On figure 6.1, draw in the space between X and Y the circuit symbol for the thermistor. 1 mark. Okay, so for this question, just need to draw the symbol of a thermistor between the two space X and Y. Then part 2, at room temperature, the potential difference PD between X and Y is 1.4 volts. 1. Calculate the resistance of the thermistor. 3 marks. Okay, so to calculate the resistance of the thermistor, first let V in to be the voltage input, which is 6.0 volts here. So we label R1 for the first resistor and R2 for the thermistor. Then the V in will be the voltage of R1 plus the voltage of R2. So the voltage of R1 will be V in minus VR2, which is 6 minus 1.4, and we'll get 4.6 volts. Then the current is the same throughout the circuit, that's labeled as I, and I will be VR1 over R1, and substitute the values given. So VR1 is 4.6 and R1 is 1000. We'll get 4.6 times 10 to the power of negative 3 amps. Then R2 will be VR2 over I, okay, because they are connected in series, then the current will be the same. So the R2 is the resistance of the thermistor, then substitute the value 1.4 divided by 4.6 times 10 to the power of negative 3, and we'll get 304 ohms, rounded off to 3 significant figures. So answer will be 304 ohms. Question 2. The thermistor is placed in hot water. The PD across the 1000 ohm resistor increases. State and explain how this affects the PD between X and Y. 2 marks. The answer for this question is, since R1 and R2 are connected in series, the sum of VR1 and VR2 equals to V in, which is 6.0 volts. As VR1 increases, VR2 decreases. This can happen as the resistance of thermistor decreases when its temperature increases. Okay, I hope you understand what I explained here. As you can see from here, the resistor R1 and R2 are connected in series. So in other words, the sum of their potential difference will be equals to V in, which is a constant 6.0 volts. So when VR1 increases, then VR2 has to decrease, so that the sum will always be 6.0 volts. Now, how to make VR2 decreases? So we know that the resistance is directly proportional to the PD. Okay, so that means the R2 has to decrease. And we know that when the temperature of the thermistor increases, then the resistance of the thermistor will decrease. Alright, so this makes the VR2 decreases. Question 7. Solar energy is renewable energy source used to generate electrical energy. A. State one other renewable energy source used to generate electrical energy. 1 mark. So for this question, there are multiple answers. You just need to write one correct answer. It can be wind, geothermal, hydropower, or biomass. B. Solar cells placed on the roof of a house, shown in figure 7.1, provide electrical energy that is all transferred to the national electricity grid. The energy output from the solar cells in 1 year is 1,500 kilowatt hour. Part 1. The initial cost of installing the solar cells is $6,000. The electricity company pays 26 cents for each kilowatt hour of energy transferred to the grid. 1. Calculate the time it takes for the payments to equal the initial cost. 2 marks. Okay, so to calculate the time needed, first we need to find the total energy needed to be generated by the solar cells. So the cost is $6,000, and we divide by the amount paid by the electricity company, which is 26 cents per kilowatt hour, and we'll get 23,077 kilowatt hour of energy needed to be generated by the solar cells. And next, we can calculate the time needed for the solar cells to generate this amount of energy. Hence, it will be 23,077 divided by the output of the solar cells, which is 1,500 kilowatt hour, and we'll get 15.4 years. Hence, the answer is 15.4 years. 2. State one assumption you have made in your calculation in B, part 1, number 1. 1 mark. Okay, our calculation assumption is the energy output from the solar cells is always the same, which is 1,500 kilowatt hour per year. Part 2. The efficiency of the solar cells used is 15%. 1. Calculate the amount of solar energy incident on the solar cells in 1 year. Give your answer in kilowatt hour. 1 mark. Okay, so to get the answer, we use the efficiency formula, which is energy output divided by energy input times 100%. Then we substitute all the values given. Efficiency is 15%, hence is 15 over 100. Energy output is 1,500 divided by the energy input. Hence, the energy input will be 1,500 divided by 0.15, which is 10,000 kilowatt hour. Hence, 10,000 kilowatt hour is the answer. 2. Suggest what happens to the incident energy that is not converted into electrical energy. 1 mark. Okay, so the answer is pretty straightforward. As you can see, there are 85% of energy is wasted. So we have all this energy gone. So this energy, which is not converted to electrical energy, is converted to heat as waste energy. Question 8. Figure 8.1 shows a battery connected to a solenoid, which is a long coil. The arrows show the direction of the current at the top and at the bottom of the solenoid. A. On figure 8.1, draw the pattern of the magnetic field due to the current inside and around the solenoid. On your diagram, indicate the direction of the magnetic field lines. 3 marks. Okay, to draw the pattern of the magnetic field, we need to use the right hand grip rule. So first we identify the current flow, which is in this direction, and use your right hand, do it in this manner where your 4 fingers shows the direction of the current, and then your thumb will be pointing downwards. So this direction is the direction of the magnetic field lines. So what you need to do is first you draw a straight line pointing downwards, and then a few other lines, curved lines pointing in this direction, and you can draw one more like this, which is around the solenoid. Okay, B. State the effect on the magnetic field lines of having a larger current in the solenoid. 1 mark. Alright, so if we have larger current, means we have stronger magnetic field. Okay, so the answer will be larger current in the solenoid induces stronger magnetic field. Hence, the number of magnetic field lines increases and the spaces between the lines are smaller. C. Each of 3 metal bars A, B, and C has a dotted mark on one end as shown in figure 8.2. Each bar is either a magnet with a pole at each end or a piece of unmagnetized iron. The forces that act between A and B and between A and C are shown by the arrows in figure 8.2. 1. State whether each bar is a magnet or a piece of unmagnetized iron. So for this question, 1 mark. The answer is bar A is a magnet, bar B is an unmagnetized iron, and bar C is a magnet. Okay, why is it so? This come to the question for part 2. Explain how you decided your answer to C part 1. 1 mark. Okay, first, how do we know bar B is a magnetized ion? Because both the ends of bar B are attracted towards the same end of bar A. This shows that bar B is unmagnetized ion. Okay, the second thing is, how do you know bar A and bar C are magnets? This is because bar A and bar C repel each other. This indicates that they are magnets. Alright, so remember that only magnets can repel each other. Question 9. During a thunderstorm, lightning strikes the lightning rod at the side of the house as shown in figure 9.1. The lightning rod is made of metal with one end buried in the ground. Charge from lightning strikes passes into the ground and the lightning rod heats up. A. Table 9.1 shows the resistance of 10 meter lengths of copper wire of different cross-sectional areas. Part 1. State the relationship between the cross-sectional area of a wire and its resistance. 1 mark. Okay, so this question is pretty straightforward. We know that the formula to calculate resistance is R equals to rho L over A. Hence, cross-sectional area of a wire is inversely proportional to its resistance. Part 2. Use data from table 9.1. Confirm the relationship in A part 1 for the copper wire. 1 mark. Alright, as I mentioned in A part 1, R equals to rho L over A. The length L is constant, which is 10 meter. Resistivity of the wire is also constant. Hence, if R is inversely proportional to A, then R multiplied by A is constant. Table 9.1 confirms this as R times A will be equals to 1.7 times 10 to the power negative 7 for each row of data. B. During the major part of a lightning strike, there is a current in the lightning rod of 30,000 amps for a time of 12 milliseconds. Part 1. Show that the thermal energy E produced in the lightning rod during this time is given by the equation E equals to 11 times 10 to the power 6 times R, where R is the resistance of the lightning rod in ohms and the value of E is in joules. 2 marks. Okay, so to prove E equals to 11 times 10 to the power 6 times R, we use the formula E equals to I square RT. The I is 30,000, hence it is 30,000 square times the R times the time, which is 12 milliseconds, or 12 times 10 to the power negative 3, and we'll get 10.8 times 10 to the power 6 times R, or 11 times 10 to the power 6 times R in 3 significant figures, hence shown. Part 2. The thermal energy produced in the lightning rod causes a rise in temperature of the rod. The lightning rod has length 10 meters, cross-sectional area 2.5 times 10 to the power negative 5 meters square, and is made of copper. Using the equation in B part 1 and data from table 9.1, calculate the rise in temperature of the rod during the 12 milliseconds. Density of copper is 9,000 kilograms per meters cube. Specific heat capacity of copper is 390 joules per kg per degree Celsius. 3 marks. Okay, so this lightning rod has a cross-sectional area of 2.5 times 10 to the power negative 5 meters square. Hence, from the table, we need to look at this row where the resistance is 6.8 times 10 to the power negative 3 ohms. we also need to use this formula which we get from part 1. Okay, so E equals to 11 times 10 to the power of 6, and then the resistance is 6.8 times 10 to the power of negative 3, and we'll get 74,800 joules. Next, we need to find the mass of the metal rod. So we use the formula rho equals to m over v. So the rho is the density, which is given 9,000, and we can calculate the mass, which is the density times the volume. So density is 9,000, the volume is the cross-sectional area multiplied with the length, which is given 10 meters. Okay, the cross-sectional area based on the table, it is 2.5 times 10 to the power negative 5, and then times the length 10. We get the mass is 2.25 kilograms. Okay, so why do we need to use the mass? Because as given the specific capacity of the copper, the formula is E equals to mc delta T. Alright, which means the change in the temperature will be the energy divided by the M and C. Okay, energy is 74,800 divided by the mass is 2.25, and the specific heat capacity is 390, and we'll get 85.2 degrees Celsius. Hence, the answer for the rise in temperature is 85.2 degrees Celsius. Part 3. A manufacturer considers using iron instead of copper for the lining rod. Table 9.2 shows data for identical lining rods made from either copper or iron. The specific heat capacity of the iron and copper are similar. The manufacturer considers a lightning strike in each rod that lasts for the same time and has the same high value of current. Based on the manufacturer's consideration, explain why the iron rod is more likely to melt during the lightning strike. 2 marks. Okay, so from the thermal energy formula, E equals to 11 times 10 to the power 6 times R, we can calculate the thermal energy produced in the copper, which is 11 times 10 to the power 6 times the R we get from the table 9.2, which is 0.017, and the value is 187,000 joules. On the other hand, we also can calculate the thermal energy produced in the iron, which is 11 times 10 to the power 6 times the resistance. Based on the data in table 9.2, it is 0.096, and we'll get 1,056,000 joules. Next, using the specific heat capacity formula, the delta T equals to E over mc. So since we assume we are using identical lining rods and specific heat capacity of the iron rod and copper are similar, then the change in temperature of the iron rod over the change of temperature of the copper rod will be equals to the thermal energy in iron divided by the mass of the iron times the specific heat capacity of the iron divided by the thermal energy in the copper rod divided by the mass of the copper rod times the specific heat capacity of the copper. Then mathematically, we change the division sign to multiplication sign, and from here we can cancel out the mass of iron times the specific capacity of iron with the mass of copper times the specific heat capacity of the copper, because we assume that the mass of iron is similar to the mass of copper, and the specific heat capacity of iron is similar to the specific heat capacity of the copper. Hence, now the ratio of the change in temperature in the iron over the change of temperature in the copper will be equals to the energy, thermal energy in the iron rod divided by the thermal energy of the copper rod, which is equals to 1,056,000 divided by 187,000, and we'll get the value is about 5.65, rounded to 3 significant figures. So the change in temperature of iron is more than 5 times the change in temperature for the copper. So however, its melting point is less than 5 times the melting point of copper. Hence, the iron rod is more likely to melt during the lightning strike. C. Describe the difference between the action of a fuse and the action of a copper lightning rod. 1 mark. Okay, so the answer for this question is pretty straightforward. Just write down the standard answer to explain how fuse and lightning rod works. Okay, you can write as fuse will melt and cut off the circuit when the current with its value more than the fuse current rating flows through it. A copper lightning rod provides a channel for the current to flow to the ground when lightning strikes on it, thus protecting the building from the surge of current from the lightning. D. A manufacturer uses two identical copper rods connected together as a lightning conductor. The rods are connected together at the top and are slightly separated as shown in figure 9.2. The currents in the two rods are equal during a lightning strike. Explain why the rods attract each other when the lightning strikes. 2 marks. Okay, so to answer this question, first we can say that when currents flow through the rods, magnetic fields are induced around the rods. Using right-hand rule, we can determine the direction of the magnetic field line. Okay, so now you can assume that. Let's look at the two rods from the top, and for the top view we can draw in this manner. So we have two circles which represents the rod. The cross represents the direction of the current which is flowing towards the plane. Then we'll hold our right hand in this manner for both rods. So the thumb points towards the direction of the current flow, and the four fingers will show us the direction of the magnetic field lines. Hence, for both rods, this will be the direction of the field lines. As you can see from the center, the direction of field lines are in the opposite direction. So we can say the magnetic field lines in between the two rods are in the opposite direction, hence cancelling each other. Next, the magnetic fields at the opposite sides of the rods are stronger than the field between the rods as shown in the diagram. Okay, creating forces of attraction between the rods. Question 10. A. State the type of electromagnetic radiation used 1. In a remote control of a television set, 1 mark. 2. In a sunbathe, 1 mark. Okay, so this question is very textbook based question. I hope you already know the answer. So number 1, infrared is used in remote control, and for sunbathe, right, sunbathe, remember it is used to tan our skin, so ultraviolet can be used to tan our skin, hence the answer is ultraviolet. B. Microwave radiation is a type of electromagnetic radiation that is used in a microwave oven. The input power of a microwave oven is 850 watts. A beaker in the oven contains water at its boiling point. The energy absorbed by the water is 45% of the input energy supplied to the oven. The specific latent heat of vaporization of water is 2.3 times 10 to the power of 6 joules per kg. Calculate the mass of water that turns to steam in 120 seconds. 3 marks. Okay, so to answer this question, first we need to calculate the total energy used by the microwave oven. We can use this formula, E equals to PT. The power of the microwave is 850 watt The time is 120 seconds, so which will give us 102,000 joules. Next, we can calculate the energy absorbed by the water, which is 45% of the energy produced by the microwave oven, and we'll get 45,900 joules. Then using the formula to calculate the specific latent heat of vaporization, Q equals to mLV, we can calculate the mass of the water that is changed into the steam. So M equals to Q over LV. Substitute the value. The Q is the specific latent heat of Q is the energy absorbed, which is 45,900, divided by the LV, which is the specific latent heat of vaporization of the water, which is 2.3 times 10 to the power 6, and we'll get 0.0200 kg rounded to 3 sigma figures. Hence, the answer is 0.02 kg. C. X-rays are a type of electromagnetic radiation used to produce images of the inside of the human body. State 3 possible effects on the living cells in a human body when X-rays are absorbed by body tissue. 3 marks. Okay, again, this question is also very textbook based question. You can find the answer directly from the textbook. Okay, so the first possible effect on the living cell is DNA damage. Second is the cell damage and death. And the third one can be abnormal cell division and growth. Question 11. Either A. Describe the effects of unbalanced forces on the motion of an object. 2 marks. Okay, so to answer this question, there are 4 considerations that you need to think about. The first thing is, if the object is stationary, it will accelerate in the direction of the resultant force due to the unbalanced forces. Okay, so this is what it means. Let's say this is a stationary object where the acceleration is 0 and the velocity is 0. Now, one force, unbalanced force is applied on it. So what will happen is the resultant force will be pointing at this direction, which is the same direction of the applied force. And it is F equals ma, which means that the object will accelerate in the direction of the resultant force. Now, the second consideration is for a moving object. Okay, for a moving object, now it will accelerate if the resultant force is in the same direction of its motion. Okay, so this is how it means. Let's say this is the object moves in this direction with constant velocity, and I have one unbalanced force applied to it. So the resultant force will be pointing at this direction with the formula F equals ma. So which means that this object will move, will accelerate in the direction, in the same direction of its motion if the resultant force is in the same direction of the moving object. And the third consideration you can think about is it will decelerate if the direction of the resultant force is in the opposite direction of its motion. So what it means here is, let's say this is the moving object and it moves at this direction with constant velocity. Now, the applied force is in the opposite direction of the moving object. Okay, so for this case, what happens is the resultant force will be pointing, if the resultant force is pointing in this direction, F equals to negative ma, then this object will decelerate. Okay, now the fourth consideration you need to think about is it will change direction if the resultant force of the unbalanced force points in a different direction. Okay, what it means here is we can draw the parallelogram diagram. So let's say this is the moving object in this direction with constant velocity. Now, when applied force is in this direction, where is the resultant force? So we can draw the parallelogram. We draw one line here and a line here. So this will be the resultant force. As you can see, the moving object will change direction. if the resultant force of the unbalanced force pointing in different direction. B. Figure 11.1 shows a climber supported by a rope on a vertical wall. The weight of the climber is shown by the labeled arrow. On figure 11.1, draw arrows to show the directions of the other forces acting on the climber. State the names of the forces next to the arrows that you draw. 2 marks. Okay, so from here you have three forces that you need to draw. The first force is this force, which is the tension caused by the rope when the climber pulls the rope. Okay, the second force is the friction, which is between the foot of the climber and the wall. Another force is the normal, where when the climber steps onto the wall, which means he applies a force onto the wall, then the wall will give him a normal force. C. A student is asked to draw an example of an action-reaction pair of forces as described by Newton's third law. Figure 11.2 shows the diagram drawn by the student. The teacher states that figure 11.2 does not show an action-reaction pair of forces. She adds that forces in an action-reaction pair have similarities and differences. Part 1. State two ways in which the two forces in an action-reaction pair are identical. 2 marks. Okay, so the first similarity is both forces have equal magnitude, which means that the action and reaction forces are always of the same strength or size. The second similarity is both forces are of the same type of forces. Okay, if one is in a contact force, the other is also a contact force. Okay, so these are the two similarities between the action-reaction pair. Now part 2, state two ways in which the two forces in an action-reaction pair are different. 2 marks. So the first difference is the forces act on opposite directions. When the action force acts on one direction, the reaction will act in the opposite direction. The second difference is they act on different objects, which means that the action force is exerted by one object while the reaction force is exerted by another object. Okay, so that, for example, for this case, when the weight of the book acts on the table, so it acts on the table, and the reaction is the table acts on the book, so they are acting on different objects. Part 3. In figure 11.2, the earth exerts a force of 10 newtons on the book resting on the table. Describe the other force in the pair. 2 marks. Okay, the force described by the question, where the earth exerts a force of 10 newtons on the book resting on the table, so this is the force described. Okay, so where is the other pair of force, which is the weight, 10 newtons. Okay, so this describes this force, which is the other force is gravitational force of attraction due to the mass of the book. The force acts on the earth at a magnitude of 10 newtons in the opposite direction of the force exerted by the earth on the book. Question 11 or question. A. Figure 11.3 shows a ray of light from a torch incident on a semicircular block of glass. Describe how to use this apparatus and a protractor to determine the critical angle for glass. You may draw the diagram if you wish. 3 marks. Okay, to answer this question, you need to briefly describe the experiment of determining the critical angle of using the semicircular block of glass. Okay, from the diagram, this is how I want to draw. First, I will draw the incident ray, the normal, and the refracted ray. So the angle between the incident ray and the normal I will label as theta I, which is the incident angle, and the angle between the normal to the refracted ray is theta R, which is the refracted angle. Okay, now I want to briefly describe the experiment, how to determine the critical angle. So shine a ray of light into the block as labeled in the diagram. As the ray of light leaving the block, it bends away from the normal. Move the ray of light along the curved surface of the block so that it leaves the block at larger incident angles. Refracted angle is observed to increase as well. When refracted angle reaches 90 degrees, mark and measure incident angle with a protractor. This incident angle is the critical angle. B. Different colors of light take different paths through a drop of water. The effect can form a rainbow when white light from the sun strikes raindrops in the air. Figure 11.4 shows a ray of white light incident on a raindrop and the path of red light inside the drop. Part 1. On figure 11.4, draw and label the angle of incidence and the angle of refraction of the red light at the point P. 1 mark. Okay, before I can draw and label the angle of incidence and angle of refraction, the first thing I need to do is I need to draw a tangent, which is a straight line touching the circular raindrop at point P. Then I can draw a normal which is perpendicular to the tangent. Okay, after this, the angle between the normal and the incident ray will be the angle of incident, and the angle between the normal to the refracted ray will be the angle of refraction. Part 2. The refractive index of water for blue light is slightly larger than for red light. 1. State and explain how the angle of refraction at point P for blue light compares with the angle of refraction of red light. 1 mark. To answer this question, we can use the formula of refractive index, n equals to sin I over sin R. We rearrange this formula. Sin R equals to sin I over n. As you can see from here, sin R is inversely proportional to the n, which is the refractive index. Hence, we can say that since refractive index of water for blue light is slightly larger than for red light, the angle of refraction for blue light is smaller than for red light. Question 2. On figure 11.4, draw the path of a ray of blue light inside the raindrop and out into the air. 2 marks. Okay, as we explained in question 1, the refractive angle of the blue light will be smaller than the refractive angle of the red light. So what we want to draw is, we will draw the blue light in this manner. Okay, and when it touches this point, so first we draw the tangent and then we draw the normal. So when the blue light leaves the raindrop, it will bend away from the normal. Hence, it will bend in this manner. So this will be the complete diagram for question 2. Part 3. Red light has a frequency of 4.3 times 10 to the power 14 Hz and travels at a speed of 3.0 times 10 to the power 8 meters per second in air. The refractive index of water for red light is 1.3. Calculate the wavelength of the red light in water. 3 marks. Okay, so since we want to calculate the wavelength of the red light, we need to know the speed of the wave of the red light in the water. So using the refractive index formula, n equals to c over v, then the v will be c over n. So the c is the speed of the red light in the air, which is 3 times 10 to the power 8, and the n is the refractive index, which is 1.3, and we get the speed of the red line in the water, which is 2.3077 times 10 to the power 8 meters per second. Okay, now next we use the wavelength formula, V equals to F lambda. The lambda will be V over F, so lambda represents the wavelength. Then substitute the value, the speed of the red line in the water, which is 2.3077 times 10 to the power 8, divided by the frequency given is 4.3 times 10 to the power 14. Then we'll get 5.37 times 10 to the power negative 7 meters. Hence, the wavelength of the red line in water is 5.37 times 10 to the power negative 7 meters.
Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.